All right. I've been told that I sometimes lecture about Stephen's head, so you probably don't know Hitler is. So why don't we just make it a little bit more personal? All right, guys. Speaking of Hitler, when do you think you're going to be able to find him and kill him if you could do time travel? By the time he looked like the way he did in the history books, he was fairly famous and it was extremely well protected. There's no way you can go near that. So you gotta find him as a little kid, right? And so you have to find every single kid whose name is Adolf and then kill him, right? That's what you need to do. You gotta look for a kid with a little funny mustache. Is that what it is? No, so you're not gonna be able to find this guy and you're not gonna be able to kill him. So forget that. So why don't we make it a little bit more personal for you? Why don't you go back in time and find your own grandfather before he fathered your father and kill him? And what happens to you?
It's a paradox.
What happens to you? Go back in time, find your own grandfather before he fathered your father and kill him.
Never be born.
Never been born, right? You're yourself fine. All right, if you're never born, who goes back in time and kills your grandfather? You don't want that, right? So which means that your grandfather is still alive, which means that you still go back in time and you still kill him, right? And then you vanish. No one goes back in time and kills him, and he's still alive. Notice what happened, guys. You end up getting two contradictory likenesses, which is known as, Jesus, what is it called? It's called
a paradox.
It's called a paradox. All of a sudden, you end up getting a paradox, which means that using the same logic, you can come up with two opposite conclusions, and both conclusions are just as valid, equally valid. So it's going to give you a paradox. The problem with paradoxes is nature does not like these paradoxes. It's going to give you a grandfather paradox. This is known as a grandfather paradox. So how do you overcome this paradox? What is it that you got?
Suppose a wormhole does twist time as well as space. Suppose NASA engineer
is what's called the grandfather paradox. The grandfather paradox says, if time travel is possible, then it ought to be possible to go backwards into time and kill your grandfather before he fathered your father. Then you've got problems.
You might tend to vanish if you shot your own grandpa, but Tigler says that quantum mechanics provides a theoretical solution. Quantum theory holds that each atom goes through all possible histories. Tigler asks us to think about such a universe, or multiverse. He supposes you would have killed a copy of your grandfather in another branching universe.
In that history, which you're now in, he does not father your father. You do not exist in that history. As a young man, anyway, what you have done is you have entered that history via the time machine. Now, if we could isolate ourselves, we would also be aware that we existed in any of the universes. It's the very fact that we are, so to speak, anchored to one of these universes, because we are interacting all the time with the other atoms in this universe, that we're unaware of the other universes.
All right, so how do you overcome the grandfather paradox? All right, so this becomes the third condition that we need to satisfy. Active time travel is going to create paradoxes, especially if you're traveling back to the past, because if you travel back to the past, you will get to alter events in the past. Altering events in the past is going to affect the present. The only way you can actually overcome the grandfather paradox, or otherwise known as the time travel paradoxes, is by creating parallel universes. So the act of time travel needs to create its own history. All right, so this becomes the third condition that needs to be satisfied. The act of time travel needs to create its own history. It sounds really, really science fictional. All right, so pick out the best answer from this one.
B.
All right, the only way to time travel, give yourself 5 points. Guys, the best answer has to be B, right? The only way to time travel is possible. Backwards and forwards in time, and that's the only time travel that we will investigate. The way it is portrayed in the movie. Act of time travel needs to create its own parallel history. And that was this guy's PhD dissertation. Hugh Everett III, that's the name that you will get. He came up with something called Mandel's interpretation. This is the competing theory of quantum theory. The first time when you're exposed to it, it sounds really bizarre. It sounds extremely science fictional. But by the time I'm done with you guys, this explanation is going to make perfect sense. He talked about these parallel universes, otherwise known as the Mandel's interpretation. This was his PhD dissertation, which was published in 1957. At the time of the publishing of this paper, he was the only person who actually believed in it, and today it's a mainstream interpretation, one of the mainstream interpretations of the quantum theory.
I've heard that there's a possibility in string theory that there are multiple universes being created at any single moment. It comes into the theory, also comes into theories of cosmology. So there may be multiple us at this moment. There's a theory that says something akin to that we're having an interview, and the other universe, the interview is different from the other universes in some other universe. Could I have nailed you just now?
I just heard that you did from the other one.
Oh, really?
Yeah.
Maybe I nailed you in this universe.
You did indeed.
Could you please come back? Maybe I'll understand it next time. Brian Greene, we'll be right back.
So Brian Greene is the face of the string theory. You will be watching A lot of it's documented.
On Nova,
Here's a big picture of what we'll do.
take a thrill ride into a world stranger than science fiction, where you play the game by breaking some rules, where a new view of the universe pushes you beyond the limits of your wildest imagination. This is the world of string theory, a way of describing every force and all matter, from an atom to Earth to the end of the galaxies, from the birth of time to its final tick, in a single theory, a theory of everything. Our guide to this brave new world is Brian Greene, the best-selling author and physicist.
No matter how many times I come here, I never seem to get used to it.
Can he help us solve the greatest puzzle of modern physics? That our understanding of the universe is based on two sets of laws that don't agree. Resolving that contradiction eluded even Einstein, who made it his final quest. After decades, we may finally be on the verge of a breakthrough. The solution is strings. Tiny bits of energy vibrating like the strings on a cello. A cosmic symphony at the heart of all reality. But it comes at a price. Parallel universes and 11 dimensions, most of which you've never seen.
We really may live in a universe with more dimensions than meet the eye.
People who've said that there are extra dimensions of space have been labeled crackpots, or people who are bananas.
A mirage of science and mathematics? Or the ultimate theory of everything?
If string theory fails to provide a testable prediction, then nobody should lose. Is that a theory of physics or philosophy?
One thing that is certain is that string theory is already showing us that the universe may be a lot stranger than any of us ever imagined.
All right, so three conditions that need to be satisfied for time travel to be possible. Time needs to be a continuum, meaning that the present, the past, the future all need to happen at the same time. And according to Einstein's theory of gravity, that's the way things are. So the question is Einstein's theory of gravity proven to be correct? Space-time continuum needs to be curved. If it's flat, you cannot do time travel. Only if it's curved, you may be able to, by taking shortcuts through the continuum, like wormholes. Last condition that needs to be satisfied is active time travel needs to create its own alternate history, the universe, so that we can overcome the grandfather paradox. So the time travel paradoxes could be overcome. All right, guys, take a break for 10. Be back for after. So I'm going to lecture about 45 minutes at a time. And then we will have discussions. And then I'll give you guys breaks at about 10, 15 minutes. All right, so take a short little break. Just go to modules, just open this up. All right, so we don't have a book, but you're supposed to have access to these documentaries. All right, so obviously communication is going to be taking place through Canvas. Also, I do have a Facebook page for this course. It's Canvas Astronomy, if you want to go there. There's more discussion material available. Facebook is better organized than Canvas usually, so in terms of the visuals. All right, make sure that you have access to each and every single movie because you will need them. And any and every movie related to time travel and in fact, any movie and every movie related to time travel and parallel universes, as well as the documentaries, even if they're not on the list. Even if it's not on the list, this stuff is still going to be extra credit. All right, so these are the recommended ones. Time travel movies, these are the ones you will get to watch and you're going to test it on. All right, so The Contact is the first one on the list. You'll be testing on this stuff 2 days from now. Today's Monday, so your test is going to be on Wednesday. And the second test is going to be on Friday. So you will get to watch 2 movies per week, along with a bunch of documentaries. We will have a discussion in class before I test you. So for you to be able to make sense out of these discussions, you have to watch these movies on time. All right, so go back to this one. All right, so here's your first assignment number 1. So it's going to be Contact. This is the movie that you need to watch. You will have 10 question multiple choice tests on a weekly basis. For every single material that we cover, there's going to be a test. Multiple choice tests are usually about 10 minutes long, or maybe at most 15 minutes long. So we will do the multiple choice test in class. The movie test, there will be 5 short essay questions. You will do that stuff on your own. I'm going to make the test available, I think, at night for a few hours. So, and I'm going to give you about 30 minutes to complete the task. I will make those tests once again available only after we go over the questions. All right. So your first documentary is going to be Fabric of the Cosmos, Illusion of Time. Something that you can find online. I'm going to provide a link here at some point. And the movie Contact is the one that you're kind of on your own. You have to find this movie. I'm going to pick 5 questions. You're looking at 9 questions. So the one out of these 9, I will pick 5 questions. We will discuss these questions in class, like I said before. We already discussed some of these questions. Like question number 3, so what are black holes and wormholes? Are they different? Who's Krypton? And so forth. All right, so let's move forward. Assignment number 1 is going to be for Wednesday. Assignment number 2 is going to be for Friday. All right, so we got 2 assignments for this week already. Topic number 1, open this one up. It's going to be motion. All right, so we will get into the physics that we need for this course. Let's try and record. This follows the lecture, so this is known as the lecture review material. This is lecture review material. I'm going to keep this course as not mathematical as possible. I don't want you guys to waste, I don't want to waste time just working on math because the math makes it complicated. It gets in the way. It doesn't really help too much. It just gets in the way. All right, so we'll go over some questions like average speed, instantaneous speed, and whatnot. So what you need to do is you need to take notes. Speaking of speed, speed is how fast an object moves in space and in time. All right, so symbolically, all right, so you have this object, mass, and I'm going to have this object move in space and in time. So the object is going to be located here at some point. It's going to travel along the x-axis, and this is the distance that it's going to travel. And in doing so, it's going to move at this speed. All right, so x is going to represent our distance. We usually express it in terms of meters. It's not relevant. Time is going to be expressed in terms of seconds. And v is going to be our speed in this case. And we usually express it in terms of meters per second. All right, so measured speed over measured time is what we refer to as average speed. So what's average speed? Average speed is measured distance over measured time. All right, so distance in time is distance in time measurements. So average speed is measured distance over measured time. So speed is how fast an object moves in space and in time, and average speed is measured distance over measured time. All right, let me just detach this. All right, so it's measured distance over measured time. All right, so speed is how fast an object moves in space. How fast an object moves in space and in time. The average speed is measured distance over measured time. The next one is instantaneous speed. Instantaneous speed is how fast you're moving at a given point in time, given moment in time. It's the measured speed. When you're driving at 45 miles per hour, you know you're driving at 45 because you can see it on the speedometer. When you get pulled over and when the police officer is writing you a ticket for speeding at 90 miles per hour in a 65 mile per hour zone, they know you're going at 90 miles per hour because they got a radar gun. So the radar gun is going to give them your instantaneous speed. So the instantaneous speed is the measured speed. The average speed is calculated. All right, so what's instantaneous speed? Your measured speed. What's the difference? Question number 4 between the average and the instantaneous speeds. Average speed is calculated. The instantaneous speed is measured. Average speed is measured distance over measured time. The instantaneous speed is your measured speed. They may or may not be the same. What is velocity? Velocity is a combination of speed and direction. It's not only how fast you're moving, but also which direction you're moving. It's known as a vector, but that's not important for you. So if you have 2 objects moving in opposite directions, do they have the same velocity? So if you have 2 objects, 2 cars moving at the same speed in opposite directions, do they have the same velocity? Yes or no? So if you have 2 cars moving at the same speed in opposite directions, so we have 1 car moving to the left, 1 car is moving to the right. All right, so this is moving at 50 miles per hour. And the second one is also moving at 50 miles per hour. They have the same speed. Do they have the same velocity? All right, guys, velocity is a combination of speed and direction, right? All right, they are moving at the same speed, but they're not moving in the same direction. Because they're not moving in the same direction, they don't have the same velocity. All right, velocity to the right is going to be positive, so velocity to the left is going to be negative. All right, so when you have 2 objects moving at the same speed, they may not have the same velocity if they're not moving in the same direction. So if that's the case, what if you have an object moving in a circle at a constant speed? So you have an object moving in a circle at a constant speed. Is the velocity also constant? Yes or no? All right, so it's moving. It's a car going around in a circle at 35 miles per hour. So it's going to be 35 miles per hour all the way around. So this is 35, 35, 35. All right, so it's moving at a constant speed. How about the velocity? How about velocity? Is velocity also constant?
Is that the one that's connected to it? Yeah. Okay. Is it even on? No. I don't know if it's not plugged in. I plug it in.
Is velocity also constant? Yes or no? It's moving in a circle at a constant speed. Is velocity constant? Yes or no? The answer to that question is it's not, right? Despite the fact that speed is constant, the velocity is not constant because the direction of motion keeps changing. All right, so velocity is a combination of speed and direction. All right, so what's velocity? Velocity is a combination of speed and direction. All right, so what's the difference between speed and velocity? That's question number 6. Speed is how fast. The velocity is also which direction. So the direction of motion matters. If you have two cars moving at the same speed in opposite directions, do they have the same velocity? The answer to that question is no, not unless they're moving in the same direction.